Let's start with a simple inventory management system, ABC classification system. When we talk about inventory management, experience tells us that out of the total inventory in terms of dollar value, most of it usually is a small number of items with high value, those expensive ones. Here's an example. In the inventory, which has 100 items, the dollar value of the inventory, let's say it's a total of $100. Among them, 15 items, in terms of the number, 15 items are the most expensive ones. The cost of these items here, of this 15 items, is $60, okay, which is a 60% of $100, while the rest 85 items only worth $40. So it makes sense to focus more of our attention and resources on those A category items, which has the highest cost and the lowest quantity, which is right here, this category, A category. This actually happens a lot and works quite well in most of the inventory management situations. So we call this ABC approach. We allocate control efforts according to the importance of the inventory category. A category is the most important. It is usually 10 to 20% of the number of items in inventory, but about 60 to 70% of the annual dollar value, the total dollar value. B category is moderately important. It is usually around 30% of the number of items in the inventory and about 30% of the total dollar value. C category is the least important. It's usually a large amount, which is 60% of the number of the items in the inventory, but only 15% of the total dollar value. So other than this intuitive ABC model, which usually works just fine, we further can improve the inventory management by using a more effective models. We're going to start in this class, we're going to start with classical model, economic quantity model, or EOQ models. Then we can further introduce the economic production quantity model. At the last, we're going to further incorporate the quantity discount into the models. So visually, the inventory cycles look like this. When we receive a shipment, the quantity level is Q. Okay, we receive the order, the quantity, it is the highest of the order time, it's Q. Over time, the consumer starts to buy and our inventory level goes down all the way to 0. So the slope here is also the usage rate. The deeper the slope, the faster the inventory sells out. After the inventory is exhausted or sells out, another shipment comes in and the inventory level goes back to the level Q again. On the X axis, we mark it as right here. Now, the question is how much to order. To illustrate, we can compare large order quantity to small order quantity. In other words, large Q to small q. The large quantity is the green one, and the small quantity is the blue one right here. For the same usage rate or slope, the inventory with a smaller order quantity runs out much faster than the large quantity. because the small quantity ones inventories sells out quicker than the large quantity inventory. For now, we consider two kinds of inventory cost: holding cost and ordering cost. First of all, we know that the highest inventory level is Q. The lowest inventory level is 0. So the average inventory level is Q over 2. Annual holding cost then, is the average inventory level, which is Q over 2, times the holding cost per unit per year, which is capital H. So annual holding cost equals to Q over 2 times H. Another cost is the annual ordering cost. The number of the orders per year is the total demand, which is capital D, divided by the order quantity each time, which is Q. So D over Q. Annual ordering cost is the number of the orders, which is D over Q, times the ordering cost each time, which is S. Now, again, the ordering cost now is D over Q times S. So the total inventory cost is Q over 2 times H plus D times S divided by Q.